Hello, this is Mr. Craig, and I want to work out the odd problems for this factor labeling or dimensional analysis type worksheet. Dimensional analysis or factor labeling is used quite a bit in chemistry. At first it kind of looks like, what are we really doing here? But this is a problem solving technique or a problem solving method that we want to use later on, especially when we get into the second semester and we start doing some stoichiometry, things that we haven't talked about yet. But this is a problem solving math technique that you'll want to master and be very, very good at. So let's go ahead and get right into it. So the questions asked, it says solve the following using the factor label method, dimensional analysis. Show complete setup and all units. So in other words, what this is saying is make sure you show all your work, all your units, all your steps. Don't use shortcuts. Use the conversions if they're given to you. Don't make up something that's close. In other words, like if you have 1 meter and you want to convert that into yards, you just say, oh, well, 1 meter and 1 yard are the same thing. They're not the same thing. They're different in their size. They're close. But what we want to do is make sure that we're using the actual conversions. First thing, this first question is a metric to metric conversion. So we want to make sure that we actually know all of our metric prefixes that at least I teach you. Some of you, if you have different teachers or different instructors, may want you to learn other prefixes, but these are the ones that I have my students learn. And a couple years ago, I had a student make up a story with the prefixes, looking at the actual symbol for each of the prefixes, and it stuck with me for a good 10 or so years, and it seems to work really well, and my students seem to appreciate it. I think in class I did a lecture over this, and I had my students, I put it up on the board and I said, I guarantee you'll learn this in 3 minutes, and they were able to get it. So here's the story. It starts off by saying, the great mega king one day caught me microwaving nasty pizza. Okay, so that's actually the saying for the prefixes that I want my students to know. So the great mega king one day caught me microwaving nasty pizza. Sounds kind of dumb, and it is. I'm not going to lie about it. But it stuck with me for well over a decade, and it'll probably stick with a lot of my students for a long time too. The way this works out is when we're looking at metric prefixes, they're all base 10. So when we look at anything, we want to make sure that we're actually looking at values of 10. And anything to the 0 power is equal to what? Very good, 1. So if I have, say, 10 to the 0 power, that's equal to 1. If I have 1 to the 0 power, that's still equal to 1. If I have 5,372 to the 0 power, still equal to 1. So that's really nice. And what we want to use the 1 for is the units that we use that are not the prefixes, like grams, meters, and liters. These are our base units. In other words, our mass, our length, and our volume. So the grams, grams, meters, and liters. So if I have, say, K in front of the G, then I have not a gram, but I have a kilogram. And that prefix actually tells us how many grams we have. Or if I have, say, the milli in front of the gram, then I have a milligram, and that tells me how many grams I actually have. Kind of cool. So let's go ahead and I'm going to write down all of the values that actually are 10, and then we'll go through and put the exponent on. So I'll fast forward this. All right, so now that we have the 10s up here, we have to remember what the values are. So I have to assign some exponents here. Well, I already had the 0 there for the 1. So what I want to do is, actually I'm going to move that guy out of here. Throw that away. Put the 0 there so we actually have something. That's not very good either. Let's get that out of there. Okay. So the way that I have my students remember it is that if you look at D, okay, in the saying it represents day, but really it represents deci, which is 1/110th. So it's a -1. In other words, if I were to represent deci I go 0.1. That's what 10 to the negative 1 represents, is that I move my decimal actually one place if I'm going to move that and make that an equivalent. So in this case here, cente is negative 2. And so I have 0, negative 1, negative 2. And again, if I'm looking at cente, then that represents 1/100th. So I now have 2 decimal places in play here. And then milli is negative 3. And then from there, we go out 3, 6, 9, 12. All right, so it's not kind of nice. So you really only have to focus on the 0, the 1, and the 2, and the 3. And then from there, we go 3, 6, 9, 12. And this side is negative, this side is positive. So there's my 6, my 9, and my 12. On this side, going this way, now I don't have a 1, 2, and 3. I go to kilo, which represents 1,000. Or if you were to look at it, it's 1,000. So there's 3 decimal places in the positive direction. So that's what that represents. And then if I look at mega, then it's 6, giga, 9, tera, 12. Now, we try to incorporate the metric system in the United States. Hasn't gone over too well. But with technology, we have kilobytes, megabytes, gigabytes, terabytes. So we slowly are integrating it in through our technology. I don't foresee us flipping over to the metric system in my lifetime. I'd be very surprised in your lifetime as well if we got rid of pounds, inches, and all that jazz. We're so comfortable with it, we don't want to change. So, but looking at this. So here is my metric prefixes: tera, giga, mega, kilo, deci, cente, milli, micro, nano, pico. All right, but if you're working these problems out, you don't really need to know those names just yet. For the test, you will. But you can call it the Great Mega King, one day, call it me, microwaving nasty pizza. And then start off with your 0 is 0, and then negative 1, negative 2, negative 3, and then go 3, 6, 9, 12. All right. This is an important table that you want to have before you start any quiz, any test, that you know you're going to be doing some dimensional analysis with some metric values. All right, so let's actually look at the first question now that we have that information. And let's get rid of our random zeros there. So the first question says, I have 500 centimeters. I want to know how many meters we have. And in some cases, well, not in this case, I don't know why I put that conversion up there, but we'll use it down here. I will give you the English to metric conversions, but if it's a metric to metric conversion, there's only one step, which is pretty cool. And you'll notice that you'll have like some base unit in there, meters going to centimeters, or centimeters going to meters. Now, if it's an English to metric conversion, like feet to centimeters, well, the English don't even use it. It's just good old America. Then I will give you the conversions for that, even if it's something as mundane as that. But I have had foreign exchange students come into my class, and they had no idea what feet and inches were. That's okay, because my students don't know what centimeters are. So, all right, so let's look at this question. Here's how we actually tackle a factor labeling problem. You have to look at the question, and you have to ask yourself a question. What do I know? What's given to me? So, do I know how many meters I have? No. Do I know how many centimeters I have? Yeah. So, you always want to ask yourself, what do I know? Before you even begin, whatever I know, that's what I'm going to start with. Sometimes I might put the question mark on this side of the equal sign, and I might put the value on this side. So don't get conditioned to think, well, whatever's on the left, that's what I'm going to start with. No, whatever you know. And that'll actually apply to later on in chemistry. Whatever you know from the question, that is what you're going to begin with or start with. So in this case here, we know that we have 500 centimeters. So I want to start with my 500 centimeters. Now, what I'm going to draw is called a factor labeling. Oh, I don't know what that is, to be honest. But whatever it is, if I move from this box or this area to this area, in other words, moving in that direction, I'm multiplying. If I move from this area vertically down, like this, then that means that I am dividing, okay? So that's what I'm doing, instead of writing out the times and the divided bys and all that jazz. So that's what I'm representing there. Okay, so here's what we want to do. We know we have a unit, centimeters. We want to get rid of that unit, centimeters, because we're trying to convert it into meters. So the best way that we can get rid of the unit that we begin with is to, quote unquote, move it diagonally. In other words, take this unit and place it in the next box diagonally. Or later on, as we'll find out when we work out some of these more fun problems, that we'll want it later on in a later step, not in the numerator, but in the denominator. If it actually is in the denominator when we start with it, which we'll be talking about here in a few minutes, then we want to put it in the numerator. Because what we're trying to do is we're trying to get our units to divide themselves out or cancel out. So if I move my unit centimeter diagonally, then that means that I have centimeters here. And since this is a metric to metric problem, it's only going to be one step. I can convert centimeters into meters. So I'll put meters on top, or whatever my conversion is. We'll talk about that here in a minute too. So at this point right now, if I look at this, the centimeter units will cancel out, and I'm left with meter in this case. All right, so we have our units in the correct spot because we want to make sure that we cancel alike terms out, and we do that by having them in the numerator and denominator. The next thing that we need to do, let me get rid of those red lines, is I want to ask myself something. Which of these two values, meter or centimeter, is larger? So I go back to my table and I look at that I've created. So I have meter and I have centimeter here. So whatever is farther to the left on this table is bigger. Whatever is bigger, we want to assign the value 1 to. So you put a 1 on the unit that is larger. And then, since this is all, again, metric, so they all have base 10 here, we're going to place a 10 down here. And then I need to ask myself, how many times do I need to move the decimal point to get from meter to centimeter? Or vice versa, to go from centimeter to meter. So if I start right here at 1, where I had just a meter, so my actual exponent is 0, and I go to centi with a -2, what that means is I need to move my decimal place 2 times to go from 0 to -2. So what that means is I'm going to place as my exponent a 2. Now, some of you might say, whoa, that's a -2. But remember, if I'm going 2 steps this way, it's the same as if I go 2 steps this way. So whether I'm moving in a positive direction or a negative direction, it's still considered 2 steps. So it's always an absolute value. And that'll make more sense once you work some more of these problems out. Also, what you can look at is, in 1 meter, there are 100 centimeters. So anything that we have above or below a value here, they're equal. That's the equivalent value. Or a conversion. In other words, like I have on here, that 1 inch is equal to 2.54 centimeters. Well, we're not using that in this problem, but 1 inch does equal 2.54 centimeters. Or if I had 2.54 centimeters, that's equivalent to 1 inch. So it's a conversion, it's an equivalent. So now that we have our values in place, we have our units where we want them, and we want to cancel those out, now we simply multiply this out. So the way that I would type this in on my calculator is I would say, okay, I have 500. You can type times 1, but you know it's going to be the same value. So I'm just immediately going to go and do divided by. And as soon as I hit the divided button, I want to open up my first set of parentheses. Actually, in this case, I'm only going to use 1 set of parentheses. And I'm going to type in either 100. You can type in 100. Not very romantic because we're going to be using some bigger values here later on. You can type this in to look like this, where it's 1 times 10 to the 2. So the way that we tell our calculator that is we say 1, and if you have a Texas Instruments calculator, you can use this button here. It's called EE. The EE button actually is a pretty cool button. It represents times 10 to whatever you type in next. So if I wanted to represent 100 here, then I would go 1 EE 2. and then close the parenthesis. Now, some of you don't have Texas Instruments calculators. If you have a Casio, maybe yours has an EXP button, and that's usually located, like if you're looking at your calculator and the equal buttons down here, usually that EXP button is right here in this area here. So it's located there. Also, you could have what's called, the button could actually look something like that. I think it might be an X up here though. But what it is, it's a function button that helps you to not have to type in times 10 and then caret and then the next value. So it speeds things up, and it's really nice. But let's get to our answer here. Whoa, what did I do? Let's undo that. Okay, so let's get our answer here. So if I look at, say, all that jazz, type all that in. Actually, I'll leave that there for just a second, get that out of there. 500 divided by 100. Hopefully you checked on your calculator and you're like, okay, well that's 5 meters. Okay. Now, very simplistic problem, but there is a lot involved, and I'm going to go much, much quicker on these other problems. It says that I have 7.20 feet, and I want to know how many centimeters that is. So again, ask yourself, what do I know? I know I have 7.2 feet, and I need to find how many centimeters. Now, I won't put all the conversions on a single problem, so sometimes you might have to look above. Generally, you don't have to look below for more conversions. And on the test and quiz, I'll give you a box with all the conversions in there, so you can access that rather easily. Some of you will accidentally learn them by just using them over and over again, and that's perfectly fine. But again, check the conversion box or the information that I've given you just to make sure that you're using the correct values. So 7.20. So 7.20 feet. And again, we're going to go more than one step because this is not a metric to metric. So there'll be at least 2 steps in this one, and that's okay. So I'll draw my factor label thingy, whatever it's called. I don't even know what it's called, to be honest. We do want to get rid of the unit that we started with, feet. So again, we're going to move it diagonally, the unit, because again, I want to get rid of that unit. And in this case, I need to change my feet into inches because I do have a conversion up here that says I can go from inches to centimeters. So that's the path in which we're going to take. We're going to convert our feet into inches and then our inches into centimeters. So that's the path I want you to take. I don't want you going, there's about 3 centimeters in an inch, and then there's like 12, and so it's equal to 36. Don't do that. You're going to lose a lot of points if you start rounding and guesstimating. I want you to use the correct values because, again, this information that we're doing here will be very, very useful in the future. All right, so we need to convert our feet into inches. And I want to show a neat little trick. I'm not going to put the values in just yet. I'm going to show the units first, and then I'll place the values in. That way, I think it makes it a little easier, especially for the beginners, to go, whoa, where do the units go? And sometimes the numbers muddy the water a little bit. So let's go ahead and put the units in first here. And again, if you want to write the numbers in as you go, there's nothing wrong with that. I'm not going to know if you did the units first and then put the values in or vice versa. So I'm not going to worry about it. All right, so if we stopped right here, we would have inches, but we're looking for centimeters. So we're going to move the unit that we now have that we don't want diagonally. So again, I'm going to put inches here, and you are given a conversion that will convert it from inches to centimeters. So now we'll put our centimeters right there. All right, so if we were to look at this and just cancel units out, the feet are gone, the inches are gone, I'm left with centimeters, which is what the question's asking for. And this is a proper path because I do have a conversion from inches to feet and centimeters to inches. So I can use that. That's the path I want to take. So let me get rid of those green lines. All right, so again, which one's bigger? Well, you don't need to really look at that. You have the actual conversion right there, but a foot is larger than an inch, so assign the larger value 1. And there are 12 inches in a foot. All right, looking at this one, now we know we have our centimeters to inches conversion. Which one's bigger? Well, an inch because it has the value 1. So we'll assign the value 1 to inches. Now, here's what I don't want you to do. Oh, good, 1's always on the bottom. It's not going to be like that. Sorry. 2.54 centimeters. And I know a lot of you find tricks and shortcuts, but please don't try to shortcut this. This is complicated at first, but it does get much easier later on. All right, so now we have all of our conversions, our equivalent values in play here. So, and again, in 1 foot, there's 12 inches. In 2.54 centimeters, there's 1 inch. So let's let our calculator do some work here. So the way I would type this in, there is no division here because it's all 1 on the bottom. So 7.2 times 12 times 2.54. Pretty easy. Hopefully everybody can get that on their calculator. My calculator says 219.456, but since I have 3 significant figures here, I want to show 3 significant figures in my answer. So my answer should be 219, and we're looking for centimeters here. Okay. We'll talk about sig figs a little bit later on. I don't know if we've talked about it at this point or not. But if you're always wondering, don't automatically type in or write down what your calculator is spitting out to you. All right, let's look at number 5. And hopefully when you look at this, you're looking at the units and you're saying to yourself, ooh, that's a metric to metric. That's a one-stepper. We know that because we have grams in both of those, which is kind of neat because that makes it really easy. But also what that means is that we're going to have to access our table or our information that we did earlier on, unless you have that memorized. I don't have it memorized, but I like to always have that nearby when I work these types of problems out. So again, ask yourself, which of these do we know? We know we have 6 kilograms. So start off with your 6 kilograms. And again, draw your little box there. I'm going to go ahead and draw the units in, or write the units in first. So again, if it's not the unit you're looking for, move it diagonally. And since this is a metric to metric, we can go from kilograms to centigrams very easily. Okay, so I have my units in play. I have what I'm looking for. The kilograms will cancel out. Now I have to ask myself, which of these is a larger value, kilogram or centigram? So I come up here and I say, oh, okay, well there's kilo, sorry. So there's kilo and there's centi. So since kilo is far to the left, and also it's 1,000 versus 100. So that means that we're going to assign the value 1 to our kilogram. And again, this is base 10 since it's metric. So we want to find out how many times we're going to move the decimal from kilo to centi. All right, so kilo is here. Now you might look at this and say, oh, there's a 3 there and there's a -2 there. So 3 plus a -2 is +1. Ooh, no, don't do that. Here's what you need to do. How many times do I move the decimal from 10 to the 3 to 10 to the 0? Very good, 3 times. So it's 3 to 0, so that means I move my decimal. I'm going to move it 1, 2, 3 times. Okay. And then from here to centi, how many times more do I move it? In other words, if I'm moving in this direction, I'm going from 3 to 0. So that means I move it 3 times, and then I'm going to move it 2 more times. 1, 2. So how many times did I move the decimal? That's right, 5 times. So all I have to do is go, okay, I'm moving 3 here, and then 2 more there. So that means that there is 10 to the 5, or 100,000, you don't need to know that. There's 10 to the 5 centigrams for every kilogram. This is an equivalent, or a conversion, a metric conversion. So once we have that, let's let our calculator do some work here. Here's how I would type this in on my calculator. I would type 6, I wouldn't put 6.00. I mean, if you do, it doesn't change anything. I would go 6 times, and this really is acting as a 1 times 10 to the 5. So that's how I want my calculator to read it. So 1 EE 5. And that should give me, as my answer, if I have it in scientific notation, that's the way it'll appear on my calculator. But I'd be willing to bet that the majority of you would have this show up on your calculator. Tomato, tomato, it's fine. My preference later on we'll talk about is showing 3 significant figures, like in this one has 3 significant figures. So if I really wanted to show this with 3 significant figures, the correct answer, the best answer would be this, because this does show 5 significant figures. Sorry, 3 significant figures. So I have the 6, and these zeros are significant. However, the times 10 to whatever is not considered significant. All right. And we'll talk about significance later on. So if we haven't talked about it yet, please don't stress out on that. But try not to write all these zeros. If you can get it in scientific notation, your life is going to be so much sweeter. All right, number 7. 1 mile equals how many meters? Now I know a lot of you run track, and you're like, that's easy. That's 1,600 meters. That's the metric mile. All right, that's not the true mile distance. So we want to use the conversions that we have at hand. Don't automatically just write an answer down. But it is a good ballpark. I mean, you can sit there and say, I know that in track I run 1,600 meters. That's close to a mile. So your answer should be close to 1,600 meters. So use that information as a quick check. Don't use it as your final answer, especially when it's a test or a quiz. So again, start off with what you know. So in this case, we know we have 1 mile. And let's draw our factor label thing here. Now again, there's going to be more than one step because I'm going from English to metric. And honestly, we're going to use all the conversions that we've seen before. So the first one I'm going to use is I want to convert the miles into feet. So if it's not the unit I'm looking for, move it diagonally. So I'm going to put mile, I'm going to put mile on the bottom, and I'll put feet on top. Okay. Then what I want to do is I don't have a conversion from feet to meters, but I do have a conversion from feet to inches. So I want to move that unit diagonally to inches. And then I need to use the conversion inches to centimeters because I don't have a conversion from inches to meters, and I don't want you to create one. So we'll go, again, move it diagonally if it's not the unit you're looking for, inches to centimeters. Then we do have a conversion where we can go from centimeters to meters because that's metric to metric. So once all of this right here up to this point here, this is our English conversions. Here's our English to metric bridge that we're going to cross in our conversions. And then we go one more step and do our metric to metric conversion. So we'll put our centimeter here and meter there. Cool thing, I'm looking for meter. Meter must be in the numerator. Can't be down here or you'll have the inverse of your answer if you do something goofy there. All right, and what I like about this is it actually cleans everything up. We don't have any numbers there to help muddy the water, and we can see, miles cancel, feet cancel, inches cancel, centimeters cancel. I'm left with meters. So now I go and I plug my values in. So I know that in 1 mile, there are 5,280 feet. You don't have to know that. It's okay. In 1 foot, there are 12 inches. I'll give you that conversion. Earlier, we saw that in 1 inch, there are 2.54 centimeters. Now, here is our metric to metric conversion. We have to ask ourselves, which is larger, meter or centimeter? And I'll go back. So meter is here. Now, don't mistake milli for meter. When you put the two together, and then you have a millimeter, but that's not what we're looking for here. So cente is here, meter is here, so meter is bigger because it's farther to the left. So we'll assign the value 1 to the meter. And then how many times do we move the decimal from meter to cente? Some of you are like, this is getting easy. Going from 0 to -2, how many times do you move the decimal? I don't care if you're going forward or if you're going backward. How many times or how many steps did you take? Don't say, well, I took 2 positive steps and I took 2 negative steps. No, you took 2 steps. So from here to here is 2. That's your exponent. So what that means is I'm going to put 10 to the 2 there. Okay. Here's how we type it in, or one way to type it in. So I can say, okay, I have 1 times 5,280 times 12 times 2.54 divided by, again, notice I'm multiplying by 1. Open my parentheses, just a good habit to get into. You don't necessarily need it on this one. And again, this represents 1 times 10 to the 2, so 1 EE, or the EXP button, or the EXP to the 10, or times 10 to the whatever, so 2, close that up, equal. Okay. So that's how you would type all that in. So 1,609. Now, if we were to put that with the correct number of significant figures, your answer would be 1,610. But I'm okay with that. Okay, so 1 mile, it's 1,609 meters. So remember that. So if you're planning on trying to break the mile record in running, you got to go another 9 meters. So may not sound like a lot, but it's a nice little distance there. It's almost 10 more yards-ish. All right, number 9. Now we're finally getting into the fun problems. Again, these up here, you start with one thing, you finish with another. These are the reason why you got out of bed this morning. And the way that this actually should be written on your paper, it should look like this. 10 gallons per minute is equal to how many milliliters per second. I apologize that I didn't have it written like that. On the test and quiz, I promise it'll look like this. So that you have your numerator, you have your denominator, it's not something that looks like that. That really does bother me. And I know it might bother a few of you. Some of you are like, what's the big deal? Just depends. So I'm going to leave that like that. And I also gave you this conversion. Hopefully you know that conversion, but I'll give it to you. So these types of problems are very, very interesting. I like them. This is a rate problem, 10 gallons per minute. Okay, so it's pouring or it's flowing or it's doing something at 10 gallons per minute. And the question wants to know, well, how many milliliters per second is that? So we start off the same way. We write down what we know. We know we have 10 gallons. I'm just going to abbreviate that as gal. And I'm going to draw my little box here, or actually my thingy. And that is per minute. Now, some of you might say to yourself, oh, wait, you don't have a number down there. Okay, well, put a 1 there. It's for 10 gallons for every 1 minute. Okay, that's what that's saying. That's why we don't put like miles per hour, because we assume it's in 1 hour's time. So if you need to have that 1 there, that's fine. If not, then that too is fine. But when we're doing our conversions, the best advice I can give you is convert either gallons to milliliters first before you convert minutes to seconds, or convert your minutes to seconds first before you convert your gallons to milliliters. Okay? So let's do that. And also, I need to give you another conversion, which I didn't put up here. I apologize for that. In 1 gallon, there are 3.785 liters. We're going to need that. Sorry about that. That will be given to you. So that is a conversion that you'll need to know, or it'll be at your access. All right, so what do you want to convert first? Or what do you think is easy to convert first? I always like starting off with the easy ones and then saving the harder ones for later. Minutes to seconds. Pretty straightforward. So here's what we do. Whether you start with the minutes or you start with the gallons, eventually you're going to have to put your unit minutes somewhere in the numerator. Well, it's the next step if we convert to time. So I want to slide my unit diagonally, so I'm going to put minutes here, and then I'm going to convert that from minutes to seconds. That is an easy one. Okay. So, and I gave you the conversion that 1 minute equals 60 seconds, so you don't have to rack your brain on that. But I'm not going to write those units in just yet. But what I do want to do is I want to note that I have my first unit completed. So I've converted my minutes to seconds. So I have my first unit converted. So now I know I'm not going to do any more with the time. I'm strictly going to focus on my gallons to milliliters. So here's what I do. I pretend that this isn't here and that this line right here is actually this line. So I'm going to take my gallons and I'm going to move that unit diagonally. So I'm going to put gallons right there. Okay, it's in the numerator. The next opportunity I have, I put it in the denominator because I want the gallons to cancel out. Now, I don't have a conversion that will get me from gallons to milliliters, but I do have a conversion that will get me from gallons to liters. So I want to convert this into liters. So again, you have to use what's given to you. And then if we stopped right there, we'd actually have our liters, but we want to go to milliliters. So move that unit diagonally. So everything on top moves diagonally. Everything that's on the bottom moves diagonally in the upward direction. So I want to get rid of my unit liters. Oops, sorry. Let's use the same color. Actually, let's shorten that. So I'm going to put liters here and milliliters there. Okay. So now I have my last unit, milliliters, that I need to convert from. And if I look at it carefully, I see, okay, well, my gallons are gone, my liters are gone, I'm left with milliliters, my minutes are gone, and I'm left with seconds. So now I have milliliters per second. Hey, I'm in good shape here. So now let's go in and put in the conversion values. So which one's bigger? A minute. How many seconds? 60. Which one's bigger? 1 gallon. How many liters? 3.785. Which one's bigger? Liter or milliliter? Ooh, that's a good question. So we come back up here, we see, oh, liters right here, milli is right there. So liter is farther to the left. So a milliliter is actually much smaller. So let's go ahead and assign the correct value there. So liter, and then again, since this is metric, let's find out how many times we moved a decimal. So if we look at milli, okay, we start here at liter, 0, milli is -3. How many times do I move to get the decimal to go from 0 to -3? Very good, 3 times. So what that's saying is there are 1,000 milliliters in 1 liter. That's pretty cool. 1,000 milliliters in every liter. Now let's make sure we can type this in. All right, so the way that I would type this in on the calculator, I would do 10 times 1, but I'm not going to type 1. If you want to type 1, that's fine. Times 3.785 times 1 3 divided by, now I got to type 1, 60. Oh, that was pretty easy. Close it, and you get a number. Okay. Trust me, we'll have some problems where we have multiples down here, but we want to make sure that everything's in that parentheses. All right, so let's get a value here. So my calculator says 630.83 repeating. So I'm going to call that 631. And what my units are is milliliters per second. Okay? So if I have 10 gallons of some liquid pouring out every minute, then that means that I'll have 631 milliliters for every second. All right, here's some bonus footage for you. All right, so I've been working out the odds. Here's an even one. The reason why I'm doing it is because of these squares. You're going to love this, I promise. Don't freak out. Let's actually write these out correctly with the numerator and denominator. So the way this should look to you is this, where it's pounds per inch square is equal to how many milligrams, sorry, question mark, is equal to how many milligrams per millimeter squared. Okay, so notice that our units on the bottom are an area, and the units on top are a mass. So it's actually a pressure. So how many pounds per square inch? How many milligrams per square millimeter? Okay. So this is what we have. Also, we have that conversion plus we have the others, that the inches and the centimeters. So we'll use all that. So again, make sure you write down what you know. So we know we have 5 pounds for every inch squared. And again, that's for every 1 inch squared. So if you need to write a 1 inch square there, that's fine. That's cool. We can live with that. All right, so what's which one would you want to convert first? And again, it doesn't matter. Since I started with this one first last time, I'm going to start with the pounds this time. That way you can see how I actually move diagonally. So converting the pounds to milligrams, well, we don't have a conversion that will get us from pounds to milligrams, but we do have a conversion that will get us from pounds to grams. So let's do that one first. So I'm going to put my pounds down here and my grams on top. Okay, so if I stopped right there, my pounds would cancel out. Now I'm left with grams, but I need to find milligrams. So we'll move the unit diagonally again. So grams go here, and since that's a metric to metric, milli goes on top. So now we have our first unit. So milligrams we have. Now we want to focus on, here, let me put that. Now we want to focus on our inches squared. Now, before I go and plug any numbers in, I'm going to do something a little bit different here, okay? I want to think about something that's squared or cubed. And the good news is our exponent for something like this can only go either 2 or 3. So you only have a linear, which is values like pounds, grams, square, which is length times width, or that you have volume, which is length times width times height. So in this case here, we're going to put inch here, and we're converting it to millimeters. Well, I don't have a conversion for millimeters, so I'm going to go centimeters. Okay, hang with me here. Hang with me. This is kind of cool. So I'm going to treat it as a linear first, then I'll go back and do the squaring. Okay. So if I stop right here, my inches are gone. Now I have centimeters. I want to get rid of the unit centimeters, or centimeters squared. So I'm going to move it diagonally. Again, to cancel out. Don't move it this way. There is no down this way. So you have to move diagonally up. And centimeters to millimeters. So there I have it. Okay? All right, so what that's saying is, and hold with me for a second. I'll do the squares. I'll actually do those conversions first before I plug in the other ones. But now I have my base unit. Inches are gone. My centimeters are gone. Now I'm left with millimeters, and technically millimeters squared. So I can circle that one. So I have the footprint in place. So let's now come over here and change these into squares. But before I do that, let me write down the linear equivalent value. So we know that when we look at an inch and a centimeter, that the inch is obviously larger. 1 inch equals 2.54 centimeters. Okay? That is a linear equivalent, or a linear conversion. However, since this is squared, what I need to do is also square these values here. So I'm going to put a square right there. Now don't find out what that number is yet. Just go ahead and square it. So now I have 1 inch equals 2.54. Actually, let me change the color on those. Let's clean that up just a little. Put green there. So square there. So I'm going to square that one and square this, which means I also square my unit. Okay. So now what that's saying is for every 1 inch I have 2.54 centimeters. If I square it, then that means 1 inch squared equals 2.54 centimeters squared. And we'll get some values for that here in a moment. But more importantly, we have the correct conversion. All right, looking at these two, okay? So again, I need to find out which of these values is larger. Centimeter or millimeter is larger. Let's go back. So centi is here, milli is here. Which one's farther to the left? The centi. And also going from centi to milli, we move the decimal 1 time, which is something that we kind of want to remember here. So centi to milli. All right, so centi is larger, so we'll give it the value 1. And the metric conversion, or removing the decimal place, is 1 time. So what that's saying is that there's 10 millimeters in every centimeter. So that means 10 to the 1. However, since these are squared, and they should be squared because we need to finish with a square here, we're going to go ahead and square these up, which means that we square these values up. Okay? Pretty cool. All right, so we have our conversions over here good to go. Let's come over here and finish these guys up, and then I'll show you how to type this in. So, which is bigger, a pound or a gram? I gave you a conversion that 1 pound equals 454 grams. So 1 pound, 454. And then, oh, let me change that color here. So 1 pound, 454. And which one's bigger, gram or milligram? You probably have this getting it down. So gram is right here, milli is right here, so gram is larger than milligram. How many times do we move the decimal from 0 to -3? We move the decimal 3 times, good. So, where are you? So gram is larger, milli is 10 to the 3. So what that's saying is there's 1,000 milligrams in every gram. We don't square or cube these guys because our units are linear, so to speak. So don't confuse that 3 with that 2 there, okay? That's what that's representing, this, that there's 1,000 there. All right, so now that we have everything in play and our units are equivalent to each other, in other words, this here is equivalent, this here is equivalent to each other, this here is equivalent to each other, and this here is equivalent to each other. Now we have some fun in typing in on our calculator. Here's how I would recommend it. 5 times 454 times 1 EE 3, or you could type 1,000 since it's not that large. Now I'm not going to do the 1 squares because 1 squared is still 1. So I'm going to open up the division sign, or actually, let's see here. So open up the parentheses. So I'm dividing. Now I'm working on everything on the bottom here. So I could do 1 times 1 times 1, but don't. But I'm going to do 2.54. And notice there's only one set of parentheses here. There's 1. On your calculator, I bet you could find what's called a square button. Okay, not a square root, square button. It looks something like that. I'm trying to think of what others look like. Most of them look like that. I'm pretty sure that all calculators have a square button. So looks like that. Now, if we have cubes, some excuse me. If we have cubes, some calculators actually have cube buttons, but if they don't, then we have to use what's called a caret button. So if you want to get into a good habit on using the caret button all the time, and a caret button actually looks like a rooftop. Looks something like this, or it looks like that. So that's a caret. If you can't find your square button, then do caret 2. All right. So these two represent the same path, but choose one of them. Don't do both. So I'm going to do 2.54 my square button, and then let's go back, times 1 EE. So I have 10 to the 1, which is 10, right? So I'm going to do 1 EE 1, and then again, either or, one of these, I don't care which one you use. I'm going to use this square button here. Actually, I'll use the caret button. Square, then close the parentheses. Okay. So again, this here, this represents that. That represents that. So if you wanted to do square button twice, good. And then let's make sure your calculator is operating correctly. Make sure that you're using this correctly. Also, once you hit that divided button, open up the parentheses, type everything in, close the parentheses. That's the only time that we're going to use parentheses. There's one set of them. And my calculator says 3,518. So, oh boy, we'll say 3,520. And what are my units on this? It is milligrams per millimeter squared. Okay. All right, last one, number 11. And it's similar to the one that we had before, except now we have meters cubed and yards cubed. And a meter is not the same as a yard. There is a slight difference, so we have to go through all the steps in the process here. Let me rewrite this correctly for you. So we have 20 kilograms per meter cubed, is equal to how many pounds per yard cubed. Okay. So that's what the question's asking. So again, start off with what you know. So in this case, we know we have 20 kilograms. And that is per meter cubed. All right. So again, doesn't matter which one you start with. We're going to convert the kilograms into pounds. And yes, I know that we all say that there's 2.2 kilograms, I'm sorry, 2.2 pounds in every kilogram, but don't use that conversion. Make sure you show all the processes or the steps here. So I'm going to start with the kilograms going to pounds first. Actually, no, check that. I'm going to do the cube first, just to mix it up, just to show you there's variety in how you can work this out. So again, I'm going to move my meter diagonally, but I'm not going to use the cube just yet. And what I want to do is I want to get the unit meter to the English metric bridge. And the English metric bridge that we've been using is the centimeter to inches. So that's what I want to go to. I want to go to centimeters because that's the conversion that I have at my disposal. So centimeters to meters. And again, if it's not the unit that you're looking for, continually moving that diagonal. So we'll go centimeters to inches. Since we need to go to yards, we need to go one more step. We do have a conversion from inches to yards, which is inches, yards. So we'll come back and we'll do that conversion here in a moment. Going from kilograms to pounds. So again, even though it's way down there, I need to put my unit kilograms diagonally in the next opening spot, kilograms. And I had the conversion from the last problem, I believe it was, is kilograms to pounds is right there. So we'll go ahead and go from kilograms to grams. And extend that a little farther. And the last thing I want to do is convert the grams into pounds. So again, move it diagonally so I get my pounds. So by doing that, now I have my pounds there. I have my yards cubed there. So I have all my units in place. All right. So now, here we go. Meter, centimeter. Which one's larger? Hopefully you said meter after doing all of these. So meters right here, centes right there. Good. So we'll put a 1 for the cente. I'm sorry, 1 for the meter, 10 for the cente. How many times does a decimal move from meter to cente? Well, it's 10 to the 0, 10 to the negative 2, so we move it 2 times. Very good. So that means that there are 100 centimeters in every meter. So we have our linear equivalent. Now, since this is cubed, what that means is we need to cube these guys up. Okay, so now that my meters cubed can cancel. So what that means is I cube that value as well as cubing this and that. Okay. So now, if I said I had 1 meter cubed, that actually means that I have 10 to the 6 centimeters cubed. Not cool? Now, you're probably going, whoa, how'd you do that? Remember that when you have your setup looking like this, we multiply the exponents. If you did something like this, 10 to the 2 times 10 to the 2 times 10 to the 2, which these two represent the same thing, then you add the exponents. So 2 times 3 is 6, 2 plus 2 plus 2 is also 6. Okay, so, but again, we'll do that with our calculator here in a moment. So this one's good. So my meters cubed is done, it's out. So now let's focus on our inches and our centimeters. Well, we know that 1 inch is larger, so put that. And then there's 2.54 centimeters in every inch. But again, this is a volume, so we need to cube these guys up. So we'll cube that, which means that I'm going to cube that, which also means I need to cube that so that we can cancel out. So now my centimeters cubed can cancel out because my meters cubed have already canceled out. Well, I'm not done yet. I got to go one more step. And what this is saying is that if I have 1 inch cubed, if I have 1 inch cubed, that means I have 2.54 cubed, however many that is, centimeters cubed. We'll find that out here in a moment. Which one's bigger, a yard or an inch? Hopefully you know that a yard is larger than an inch. And I would give this to you because I know that not every one of you know that there's 36 inches in a yard. Hopefully you do, but if you don't, no problem. But that's the linear equivalent. Now let's go and cube those up. So if I cube my unit, and I cube my number, cube my unit, I cube my number, so I'm good to go. So now, if I stopped right there, I have my yards cubed. Boy, doesn't that look busy? That looks really, really busy. That's one reason why it's probably a very good idea. Write your units in first, then go put in your equivalent values there. All right, so from here on out, pretty straightforward. So kilograms, which is kilogram larger or smaller than a gram? Very good. Kilogram is bigger. And again, it's farther to the left. So kilo is here, gram is there. How many times have we moved the decimal? 3 to 0, 3 times. Awesome. Okay, you guys are getting it. So we put our value 1 there and 10 to the 3 there. Now this is not a cubing situation because our units are not cubed. And I don't know of mass cubed, so don't get that crazy or creative there. All right, and then looking at pounds and grams, that conversion was given to you in the last problem, so that 1 pound equals 454 grams. So obviously you know that the pound is larger. So put the 1 there and 454. All right, so now type this in. Let's see here, that's a fun one. This will be a fun one to type in. So 20 times, I'm not going to do 1 cubed because 1 to any power is still 1. 2.54. I'm going to use the caret button here because not many of you do have cube buttons. So caret looks like a rooftop. It's usually located on the left side of most calculators, but again, search for it. Caret 3 times 36. Oh, sorry. Yeah, 36. Yeah, let's go there. 36. Same thing. Caret 3 times 1, because again, this represents 1 times 10 to the 3. So 1 EE 3 times 1 divided by, open up the parentheses. Oh good, we only have really 2 things here. So 1 EE 2, but we have to cube it, so caret. So caret 3 times 454. Okay. Oh, and close the parenthesis and hit equal. Okay. And if you're following that sequence exactly as I have it typed out here, you're going to get the right answer. So it's just a matter of making sure. There's actually two things going on here. You're learning how to input all this information and also how to use your calculator correctly. And by all means, once you've watched this video and you're just like, what is a caret button? Make sure you come in the next day and ask me, Mr. Craig, where's my caret button? So I can actually show it to you. All right, so let's type all this in. And my calculator says like 33.68083075. So let's say that's 33.7. So 33.7. And again, my units are pounds per yard cubed. I hope this video was helpful. Again, if you have any questions, please do not hesitate to ask. You're going to have plenty of time to work on these in class. Don't wait until the day before the quiz or the test to say, Mr. Craig, I don't understand. Not a big fan of that. If you have questions, ask me now as soon as possible.